Hello, people. Today, here I am with the topic of biochemistry, that is folic acid. Folic acid can be studied very easily in just 5 minutes and a few headings. Now, the first heading comes here is chemistry. So, it has three components: pyridine, PABA in the sense para-aminobutyric acid, and glutamic acid. Pyridine plus PABA forms steroic acid. This steroic acid together with the glutamic acid forms the terol glutamic acid, which is nothing but the folic acid. So, folic acid is chemically called terol glutamic acid. And sources, it is mainly found in the green leafy vegetables, but the rich sources are liver and yeast, and the good sources are meat, fish, and cauliflower. What is a recommended dietary allowance? In adult, it is 300 micrograms, and in pregnant lady it is 500 micrograms due to the demand of the baby. And next, folic acid has its coenzyme form, that is tetrahydrofolate. This tetrahydrofolate, how it is formed? Folic acid 2 times on reduction, NADP dependent folate reductase. In such a fashion, when reduction takes place for about 2 times, you get tetrahydrofolate, which is its coenzyme form. Now, absorption. How this absorption is taking place? It happens in the upper part of the jejunum. In nature, we find the folic acid as polyglutamates, which is not absorbed in the body. So it has to be degraded into monoglutamates by deconjugase enzyme. This deconjugate enzyme is produced from duodenum and jejunum. This is absorbed in upper part of the jejunum, transported to the liver by beta globulin. In liver, it is stored as THF. Its transport form is methyl THF. Storage in the form of glutamate in the liver. So what are the functions? Important function is it is participating in the 1-carbon metabolism. It transfers the 1-carbon unit. So by this way, it have two functions: amino acid metabolism and DNA RNA synthesis. How this DNA RNA synthesis is happening? Firstly, appearance synthesis and thymidylate synthesis. So histidine metabolism produces fig glue, that is formamine glutamic acid. The formyl group is accepted by the tetrahydrofolate, converting to the formyl tetrahydrofolate that forms the C2 of the purine, and it also forms methyl THF that forms C8 of the purine. And we know purine is an important component in the DNA. Secondly, thymidylate synthase. Uridine monophosphate is converted into thymidine monophosphate by conversion of methyl THF into THF. So the synthesis of purine and thymidylate, both of them are essential for DNA RNA synthesis. Amino acid metabolism. Serine is converted into glycine. Catabolism of histidine to fig glue. Homocysteine is remethylated to form methionine, and formation of ethanolamine and choline. So folate trap is very important one. Very important. So vitamin B12 is converted into adenosyl B12, which is a main storage form. So this happens by conversion of methyl THF into THF. It liberates the free THF for participating in the 1-carbon metabolism. If vitamin B12 is deficient, methyl THF level is increased in the blood, and also this is returned back by reaction. Homocysteine is converted to methionine. If B12 is deficient, so this reaction itself do not take place, and homocysteine levels also very increases in the body. It lead to the homocystinemia. What are the deficiencies? So it is an important and common vitamin to be getting deficient. The main causes would be pregnancy of high demand, hemolytic anemia, which I'll be telling later, and defective absorption due to the jejunum resection. So, and some drugs like phenobarbital, oral contraceptive, which inhibit the deconjugase enzyme manifestation, macrocytic anemia with megaloblastic feature. So, what is the etiology? The reason. So, RBC maturation do not occur because DNA synthesis do not takes place. That lead to the macrocytic RBC, and these abnormal RBCs get destroyed in the spleen. That lead to the macrocytic anemia with megaloblastic feature. Very important, megaloblastic feature. In the first trimester of pregnancy, folic acid is deficient. That lead to the defective neural tube formation, that is spina bifida, anencephaly, encephalocele, that is improper closure of the neural tube. Homocystinemia, which I told before, if it is greater than 15 millimole per liter, it causes coronary artery disease. And histidine load test, when folic acid is deficient, methyl THF is not formed, fig glue, its formyl group is not accepted, and fig glue in urine become increased, and cancer, bronchial cervical cancer risk also increases. Thank you. If you like this video, please share with your friends. If anything is missing,